Okay, so here I am messing with plants. Still stuck inside during the crisis here, and decided I'd plant some stuff because I'm going to be in there. This is a philodendron. It's one of my favorite plants, actually. One of the more easy plants to grow. If you want to know how to do it, it's pretty simple. You kind of just cut a leaf off, and see how it's got a root there. You just sort of plant that guy and it'll grow, and that's how I've created this. But the real reason why I'm out here this morning, at least videoing, is because I got to thinking about something called chilling requirements. And chilling requirements are basically a plant's need to cool off. And if they don't, they won't flower. And so when you have temperatures changing like this, you have plants that don't reach what's called a chilling requirement. And a chilling requirement really is it's a plant's need for cooler temperatures. And they don't get them, they don't function properly. Now, climate, or at least temperatures in Delaware, have been a little higher than they should be for the winter and for the fall, by about 2 degrees. And we've gotten more precipitation, which is great because plants love water. But those 2 degrees sort of matter. Like, a chilling requirement is a plant's need to get to a low temperature in order to start blossoming at, I guess, the right time. So take the plant behind me, for example. This is a peach tree, and it is currently 44 degrees out. And last night it got down to about 31, and here it is, just as happy as could be. And if it doesn't reach those temperatures, what ends up happening is it doesn't actually bloom, or at least it doesn't bloom on time. And if it doesn't bloom on time, then the peaches don't grow, and, well, I don't know, you sort of get it. So it's not an exact science, but at least it helps explain why plants bloom when they do, where they do. And imagine, for example, these 2 degrees that we have gotten here in Delaware. Arugula. Imagine those 2 degrees mess up those chilling requirements for the plants around here. For example, right there, that's a mulberry, and there's no blossoms on it at all, I guess because it's just not quite time. And then over there's some pear trees. Again, no blossoms at all. The peach is really happy. But imagine those 2 degrees don't allow those trees to blossom. Imagine that happening countrywide, on a more like a global scale. Imagine what that does to the available fruit. So that's a chilling requirement. And if the temperatures continue to follow this path, imagine what would happen. So, for example, when I'm talking about these chilling requirements, I'm talking about the trees. And if I'm talking about the trees, I'm talking about the blossoms. For example, these little blossoms right here, these are peach blossoms. And imagine for a minute that the temperatures don't quite get low enough for these blossoms to open up. If they don't, what are the bees going to do? And if the bees aren't pollinating, what's going to happen to them? Not to mention what's going to happen to the fruit that this tree should bear. So here's a pear tree, and you can see nothing. Now, that's probably because the pears, they don't really pop up until later. I mean, the pears, at least around here in Delaware, they're not going to start to even form for another couple of months, and then they won't be ripe until probably pretty deep into the fall before you can really eat them. But there's nothing here. This plant is not dead. I mean, it's got little blossoms on it. I don't know if you can see them. There's one right there. But it's not remotely blooming yet. I mean, you go to Washington, D.C., you get the cherry blossoms. Well, they're in full bloom right now. And then like over there, I've got my peach tree. Just shift it in your head a little bit, 2 degrees this year. Because this year, I mean, we've measured it. If you look at the weather underground data, and you look at the averages for the 30 years, and then you look at this year, both February and March were 2 degrees above what 2 point something. You know, look it up. You can fact check me. But the temperature is higher, and if you don't reach that range, or at least you don't reach it right, it sort of messes up the whole system, doesn't it? I mean, it makes sense. And then again, think of this on a global scale, or at least just a national scale for the United States. I don't know. It's worth thinking about. You know, 30-year averages, they're long-term. Climate is long-term. All of these changes are long-term, and it's difficult to tell if we're trending or if we're just in a pattern. Well, I would argue that we're probably trending based on everything I've learned, but I mean, it could be said that it's a pattern. But either way, based on just these little tweaks that you do to the system, there's things that we should pay attention to. And if the food system is based very much on temperatures and precipitation, and those are the two main factors of climate, and they're changing, you have to assume, at least at some level, that the system itself is going to change. I mean, it makes sense. I invite everybody to post comments, argue this point. Let's make sense of it. But it's weird. I mean, think when I'm stuck by myself, I just think. I wonder what you guys think.